my life.
You submitted it in 18 minutes? I probably think you cheated.
All right, let's get started.
I waited for 40 minutes and like.
Second to last lecture, are we ready? Let me start off by saying today we are starting week 14, as you can see, April 13th. Tuesday, we finished week 14. Did anybody notice Canvas? Let me bring it up. I think I'm not online though. Darn, I'm not online. I can't switch. What will you see if you go to Canvas? That you don't turn on the homework. So you just turned in your last homework assignment for the semester. I swear I thought I heard someone start applause. I don't know. I was just hearing, man, oh. No, I thought I actually heard it. Is that Olivia? I don't know. I thought I heard it. Usually it's contagious, so I gave applause. It's my bad. But, so no more homework, but we have one more in-class assignment. So here's what I had to do. If you go to Canvas, you'll see the new grade estimated work web spreadsheets there. Here's what it looks like. Here's what I did. This has to be 100%. So I put a 0 in for week 14's homework. Now each homework had to be increased to 1.81818. No. So there's more weight on all the previous homeworks, including the one you just handed in, just so you know. So that's all that's had to happen. So I spread the weight of the 14 among all the other homeworks evenly. Go ahead, Ahmed. What were you going to say?
I was asking, I thought you were just going to keep and drop the words.
No, I don't know how that was. If that was a rumor, could you crush that, please? Okay, now let's get into the new stuff. Week 14. Whoop. The very last week. Whoop. I closed the instructions. I can't believe I closed it.
That's.
Jeez. Hang on. Week 14 instructions have this one assignment, do never. Oh, I can't believe it. How lucky was that? Blah, 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 blah. Here's some reminders though. Okay, evaluations. Here's where we're at on evaluations. The website says there's 7 people who haven't done the evaluation yet, but my spreadsheet says there's 13 that haven't told me they did the evaluation. They haven't sent me that picture, the completed, screenshot. So that means there's 6 people who have completed it, but never sent a picture. So here's how I do this. You still have until, the 18th, I guess. But if this ends up, let's pretend this was it and it closed out. If these 6 people never send that picture, I take 6 divided by 13, and I give all 13 people that portion of it. Because I have no idea who these 6 people are out of the 13. So I give 6/13 that portion of it to all 13 people, so they all get part of it. It's the only thing I can think to do fair, because I have no idea who it is not sending the screenshot. I don't know what's 6 divided by 13, so at so you're either going to get 50% of that credit, or you could get it all if you send the screenshot. If you happen to think, I did do this, if you're one of the 6 people that said, I definitely did the evaluation, but maybe you don't remember sending me that screenshot, look at your emails and see if you did or not. You want to get that in. Next, last day to hand in late submissions. God, I looked at the names and I can't think of who they are right now. But they're in this room. There's 2 of you in this room. You're not looking at your grades. Who is it? It's on the tip of my mind. I don't know, but look at your grades. There's at least 2 or 3 zeros other than Amir. There's 7 there, but he's taking care of that. He's taking care of himself. Amir, are you here? Amir, just checking. All right. But a couple of you don't realize you have a 0, I can tell. I mean, one of them's like back from week 3. You got to look at your grades, you guys, and realize you forgot an assignment back then. There's like 3 of you in here that forgot it, and I can't remember who you are. But you can still get a 40 on it. Why not turn the 0 into a 40? It seems crazy to leave it as a 0 when it's so easy to get a 40. The answer is posted. What else? Final exam, yes, it is Tuesday, 1.5 weeks from right now at 11:30. New stuff. I'm jumping right to this, right here. Here's the most important part of today's lecture, right here, right there. Jumping right to it. Maybe I'm hoping everything else will make sense if I can just start right there with the stuff I was going to end with anyway. This says plus or minus. I'm sorry, not or. I should have corrected you, yeah, that's because of what you said earlier, Cole. This is and, plus and minus, not or, and, plus and minus, 3 times the standard deviation over the square root of the sample size. This is the standard error for the sample mean standard deviation. And you only use this when you're given a standard deviation. There's 2 types of problems in week 14. Those that have the standard deviation and those who don't. If they don't have the standard deviation, you're going to learn that on Tuesday, and you're going to use proportions. That's all. It's just like the last 3 weeks homework. That one's going to be proportions. This one with the standard deviations is using the sample size just like this. The standard error for the mean, this is called. Let me say that again. The part in the parentheses is the standard error of the mean, which has been the denominator for the last 3 weeks that we used means and standard deviations with. That denominator. On Tuesday, it's the denominator for the proportions that we've been using for the last couple weeks that we're going to be multiplying times 3 and adding and subtracting. That's what it is. The homework now, if you had to hand it in and you said, oh, I got to do this, you have all the information. It's that easy. You would go, what's the number in the problem? The number given in the problem is called your center line. In this case, it'd be the mean given in the problem. The mean that's given to us would be your center line. Let me give you a quick example. Right here. A firm that produces 1 gallon jugs of milk wants to ensure that the machine is operating properly. Every 2 hours, the company samples 25 jugs and calculates the following sample mean filling weights. And there it is. What should the machine fill them at? It says, assume that when the machine is operating properly, the mean is 128 ounces, standard deviation, 2 ounces. That given mean is called your center line on quality control. And your control chart starts with that center line that you just read. That 128 all these jugs of milk are supposed to be is the center line. Now what you're doing is you're calculating what's called the upper and lower control limits. Upper and lower control limits are calculated based on that center line and this calculation right there. That's how easy this is.
What was the control chart?
You ready?
Control chart.
That center line that's given is the beginning of making the control chart. The control chart has upper and lower control limits that you have to calculate and put on that control chart above and below that center line. And this is how you calculate those upper and lower control limits. This formula right here. Adding to get the upper control limit, subtracting to get the lower control limit. The same exact equation though, 3 times whatever the standard error is. So let's do this one now. Oh, wait, almost forgot. How many times was this quality control inspector went in and did the inspection with the jugs of milk? How many do you see up there? How many results do you see?
6.
6 of them. 6 times. That's fairly normal. Quality control, especially when the company's doing it every 2 hours. What I want to point out is, what that company's doing every 2 hours, because they're the ones producing the milk, they're the ones whose machine's putting it into the gallon jugs, that's called detection quality control. Detection quality control, and it's done by the manufacturer. Now, are you ready? They're doing it themselves 6 times. But let's say they have they're a huge producer of milk, and they have a huge client like Walmart, and Walmart, before they'll accept this thousands and thousands of dollars in milk jugs, Walmart probably doesn't do this. This is famous in the car industry, by the way. The car industry always does this. But let's say Walmart says, we want to do our own quality control inspection before we accept this load of milk, this huge truckload of milk. And so they'll send someone over, someone comes over with a laptop, takes the things, hooks it up USB, takes the gallon jugs, measures it however the thing is. Maybe it's pouring it in or whatever it's doing. It's going right through to the other end into an empty gallon jug, but it's measuring every drop going through to the exact 1/100th of an ounce. And it does that, and it's randomly picking, making sure every jug has a chance to be part of that. How many did the story say that they're picking? 25 jugs at a time. Pour the 25 in there, pour it through. Get those measurements, it calculates the mean. The first one is 128.7. Do it again. Those are done. We got thousands here. Let's grab 25 more at random. All of them have a fair chance. Do it again. That comes out to 120.4. When the buyer, who's going to buy all this milk, sends their own inspector over to do this kind of inspection, that's called acceptance quality control. Acceptance. It's done by a buyer. Acceptance is almost the standard between auto industry and top tier suppliers. I used to work for a tier 1 supplier, and this was standard. Now, what you're going to learn in the quality control in manufacturing is they go after certificates. Like, I can't remember the names of all of them. They've been around so many of them now. ISO 9000, ISO 3000. They have all their different names. The reason these companies go after these certificates is their badge saying, we do quality control. And the buyer, the company who's going to buy these parts from the supplier, are saying, okay, we don't need to do some acceptance quality control inspections with this particular supplier so often because they've gotten their certificate for good quality control practices. That's what the certificate is, the ISO 9000, That's the kind of relationship you have. But it doesn't mean that the buyer is still not going to do their inspections. They still do them, but they're not as often, and they're random. And keeping the supplier honest. But it's all about quality. Now, I want to tell you something. You guys are way too young. None of you were born yet. But when I was a kid, my parents would go and get in a car, and that car would last maximum 3 years. It would never make it to 100,000 miles. The quality of automobiles back in the 60s were so bad that it was like, everybody would be a big, huge story. You got a car over 100,000? How'd you do it? How'd you get a car over 100,000? That's unbelievable. Wait a minute. You don't have a ton of rust? You have not lost the whole bottom of your car with rust at this point? That's how cars were made. And now, today, I hear about cars making it over 200,000 all the time. Has anyone else heard that, or am I the only one who hears that? You've heard it? You heard it? Yeah. Cars making it over 200,000, still with no rust. They got that all figured out even. The quality is so much better, but the quality's improved down to the little ball bearing even, is how much quality's improved in manufacturing. Quality control was a revolution in manufacturing and just made everything better. Everything better by. In the old days, when I worked for the consulting firm, I got to work with a lot of manufacturers who had these machines. They'd have warehouses bigger than this room, but they'd have a manufacturing mean pounding steel over there, ba-boom, ba-boom. Another one over here flipping out cha-ching, 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 and so on. And I'd say, how often do you have to keep adjusting these machines because of the vibration on the foundation? Having multiple machines all going at the same time causes these machines to go slightly out of whack. So they do things like inspect it every 2 hours, specifically because they know this is going to happen. These machines going out of whack, where you got to go back and fix them like that, that's called chance variation. It's really out of our control. And if it's something that is in our control, that is called assigned variation. It can be identified, it can be corrected. But the example I gave you, they're not going to shut down the other 3 machines to stop the vibration on the foundation just so this machine can do its job. These machines, when they invest millions of dollars in these machines, they want them running 3 shifts. They want 3 shifts running. They want the investment, return on the investment into these machines. They have to make payments on these machines. Everybody was saying, why is interest rate such a big deal? Because companies are buying $1 million machines on loans. And every time the interest rate changes, it changes how much they have to pay on these loans for businesses to grow and buy these expensive machines. So anyway, chance variation and assignable variation. Assignable variation is something where it's a one-time occurrence, we identified it, we can fix it, and now it's not going to happen anymore. That's easy. But these chance variations, and the most common being vibrations, Vibrations within a plant, a manufacturing plant, is one of the most common ones that cause machines to go out of whack. So they have to keep checking them and keep making fine adjustments. Now, I want to show you, if we know now the center line's 128 ounces on each gallon, look at how we discovered the upper and lower control limits. We took 128 gallon jugs, since that's our center line, and we added and subtracted this calculation. Now, here's the main mistake that happens. Do not add and subtract until you did this whole multiplication, division, square root calculation. The very last step is to add and subtract. Let me say that again. If you add that 3 and subtract that 3, you will be so far off from the correct answer. Do the whole right-hand side, then add it. Do the whole right-hand side, then subtract it. That's how you get your upper and lower limit. We want this machine to be filling every jug at 128 ounces, but if it doesn't, we can't have it on average going above 129.2 or below 126.8. 3 standard errors above and below is kind of the industry standard, but there are companies out there that want better quality than just 3 standard errors above and below. So when you go to a company, and they happen to be manufacturing, which if you stay around Detroit, there's a lot of manufacturing, so it's possible. Some of them will train you and they'll say, we only want to go 2 standard errors above and below, or 1 standard error above and below, or 2.5. And they have their own ways of doing the measurements, and you will learn that while you're there. Which, by the way, I forgot to open that up. That's probably the last for some of you who won't even show up next week. All right. Right down. All right, here's my question. You ready? We're doing the inspection, 25 jugs. How many times we did the inspection? You guys said 6 times. Should we adjust this machine and stop production and make the adjustments? Or can we let production continue based on this inspection? That's my question. What do you see up there? Give me the answer and why. Why?
Good.
Good?
No.
No? Yusuf, you with me?
What happened?
What happened? Oh my gosh. No?
I say keep going, it's fine because all the numbers are going to be UCL and LCL.
Oh! Right at the end of the semester, Jason. Right there.
Finally woke up.
Man, up, Air 5, all of it. Man, you're all about it. He noticed that every one of those inspected means fell within the upper and lower control limit. And because they're all within the upper and lower control limit, you can let production keep going. There's no reason to stop it. It's the moment that your inspection falls outside the upper and lower control limit that you halt production. And you make the adjustments that need to be made, because money's going to be lost. Because on the other end, the buyer who gets all this milk or gets those parts in the auto industry won't accept it and won't accept the load if their inspection doesn't stay within the control limits, and it costs thousands and thousands and thousands of dollars to fix the problem. This is why in the auto industry, all of them I was involved with, they sent their acceptance inspector, the buyer inspector, sent it to the manufacturer to do the inspection before the truck shipped it. Because if they found a problem, they were not allowing it to be shipped. They said, we're not paying for this if it didn't fall within those upper and lower control limits. That's how important quality control is. And so now they have these thousands that the company who made them have to go through them and get all the defective ones out of there and make other ones to replace it so this order can be. The amount of money it takes for the manufacturing company to get the defective ones out and make new ones to replace it is huge. This is why detection inspections started up, and those quality control certificates for manufacturers started up, because they realized we would save money doing our own quality control to make sure they'll always be shipped to the buyer, so that we never have to do that again, picking out all the defective ones and remanufacturing them. The amount of money that costs compared to having our own quality control people is easy. It's an easy decision. So they started having their own quality control people. So now you see all manufacturing companies doing their own in-house, not necessarily every 2 hours, but if it's something really important, it's every 2 hours. And it's such an easy job, you guys. You're just going and getting the stuff and putting it through the machine, and it's a matter of you're going to be trained on how making sure that every one of those ball bearings had an even chance of being the one of the 25 or 30 you selected to put through the machine. And you gotta do a little math maybe, and just that little math scares everyone else off, and you're the person that's gonna get the promotion and has the road of opportunity. So just let you know, it's a great, great career. All right, now, we got our upper lower. Lexi, you wanna add to that? I thought you raised your hand. Upper and lower there, I wanna show you what it looks like on a control chart. What, oh my God, the one thing I haven't, right here. This is so important, I forgot. My bad. That sample size in this calculation is not the number of times the inspection was done, like 6. It's how many every time the inspection was done, how many were used. That's the sample size. So in this case, it says the company samples 25 jugs each time, and there was 6 times. I want to say this again because I know it happens every semester. Someone's going to, a problem like this, they're going to use 6 as the sample size. No, it was done 6 times, but each time it was done, the sample size was 25. So you've got to use the square root of the sample size of each batch. The 25, each batch. Don't mix it up with how many times the test was run. That's what I wanted to point out about sample size. So we got all the definition. I want to show you a control chart, what it looks like. That is a control chart right there. Those are the 6 inspections of the milk and how far it was above and below 128 ounces. And look at how and the chart shows that we're inside the upper control limit. See, I don't know what color those lines are because I'm colorblind. I think the bottom one's blue because it's dark, but I'm not sure.
Blue, green, red.
Is it, which one's the top one?
Blue, green, red.
Red's the top. The red one's your upper control limit. The blue one is your lower control limit. The green one's your center line right at 128. The dots are each one of those inspections. We connected them. Now, I want to tell you something in real life. Let me just put a quick control chart here. Okay, there's my control chart. Here's my center line. In real life, the dots are more like this. Like that, up and down all around the line. When I see a straight line in real life like that, it's telling me there's something going on with that machine and it's about to go below the lower limit. And why not make the adjustment right now? But on a test, we're not talking about real life. The question will be, would you make an adjustment on the machine right now or let it keep running? You would let it keep running because all of them are within the upper and lower control limit. That's the hardest part of week 14 for you right there. Is analyze whether you should let the machine run or not.
But we can't say that it's decreasing. It's going down.
It is going down. When you see a straight line like that, which is shocking really, because or they didn't really do random selection possibly.
So like one more sample, it would go below.
If it
right?
did, it probably would. That's usually the case when I see something like that from years ago.
So we can't explain it like this? Like say
No.
that we should fix
No,
the
you
machine.
can't explain that like real life. You gotta explain what you see.
What you see.
What you see. And since all of them are within the lower and upper limit, you would let the machine go. Now, if you want to put a little asterisk and say, but our professor said, in real life, we might want to go and make adjustments now, yeah, but there's no extra credit, so why do it?
Yeah.
All right. Where are we at? Should I look at my notes? What are we doing? We have an in class? Oh, almost forgot. Oh, where's it at? Here we go, right here. Acceptance sampling. Since you're doing your references, acceptance sampling, PowerPoint chapter 7, slide 58. Used at the completion of a production process. If a particular product does not conform to certain specifications, then it is either discarded or repaired. Disadvantage, it is costly to discard and repair product. The detection of all defective products is not guaranteed. Detection approach. Inspection occurs during the production process. This is the one the manufacturer does, the detection approach. This was developed after the acceptance approach was. That detection, companies started saying, oh, we're spending money doing our own inspections. We want to make sure this is going to be accepted by the buyer. And then they started getting certificates. Types of variation, goal is to determine whether the production process should be continued or adjusted before producing a large amount of defects. That's the whole thing about quality control, is catching the machine before it makes too many defects, to make the adjustments so it keeps making good product. The older machines, by the way, in real world, the older a big, giant manufacturing machine gets, the more it gets, for some reason, gets out of whack, and you have to make adjustments, more often adjusting it, the older it gets. That's in the auto industry, There are certain production people who don't do production, they do nothing but wait for those machines to need adjusting and fixing, and they're called skilled trades, I think. And they get paid a lot more than the regular production. And it's all about keeping those machines making good product. It's all about quality control. So you can see how much more money there is being the person who says, yeah, I can do a little math, put me in quality control, instead of just, the regular job. So it's a great entry-level job. Types of variation, chance variation, again, these are the ones that are caused by a number of randomly occurrence events. There's part of the production, they're not controllable by any individual worker or machine. Like I'm saying, the most common is vibration from the foundation, from multiple machines going. There's no way a company's gonna turn off the other 3 machines to stop the vibration for this machine to run longer without having to adjust it. Because when you stop a machine, it's not a human, it doesn't have to sleep. You wanna capitalize the profit on that machine since you're investing millions of dollars for the machine. So you wanna run it as much as possible. You wanna make as much product as you can. You're paying the same overhead for the building, whether that machine runs 1 shift or 3 shifts. So why not run it 3 shifts? Your overhead's no more other than maybe you have to turn off electricity if you shut down, I guess, at night, but the amount of money you make running the machine at night and having the lights on is so much more, you wanna keep it running. It's when demand slows down that you have no choice but to cancel a 3rd shift, because the demand's not there, you will make too many and we'll have to house it all. Assigned variation are ones that can be identified and can be corrected. They're not done by just because of things like vibration that are gonna continue to happen no matter what. What other definitions do we have here real quick? This is all for your multiple choices. Control charts, we talked about it, has a center line, an upper control limit and a lower control limit. And here's the calculation, 3 times the standard error from the mean and minus 3 times the standard error. So the upper is adding 3 times and the lower limit subtracting 3 times. There's the milk chart again. Look at how they're all within the upper and lower control limit. And then, let's see, control chart. This is proportions, I think. Is this proportions? Anyway, standard error of the proportion, same thing. You add and subtract, but if it's a proportion, you're going to use the standard error proportion formula, which is the given proportion times 1 minus the given proportion divided by the sample size, square root the whole thing. You're using that one instead, if it's a proportion involved. You'll know if it's a proportion because it won't have a standard deviation anywhere in the problem. That's, if you have to divide or something to figure out what that proportion is, you'll know it's a proportion because there'll be no standard deviation. There's a chart with proportions. We're gonna see that on Tuesday. We're going more detail on that one, so ignore it. Before we ignore this chart, you're gonna be asked on Tuesday, with this process, manufacturing process, should it be stopped and corrected, or can it keep going?
Stop.
Because it's over which limit?
The upper
The upper limit, that's right. Here's my favorite slide. Bam.
For assignable variations, what are factors that would cause it? Assignable variations, what factors would affect it?
I can't think of one offhand that may have happened. Usually they're caused by some accident, like let's say someone's forklift ran into a machine which caused it to go slightly off, but didn't report it. So now this machine's making defective material. Quality control catches that it's making defective. We try to figure out what happened. We realize it was a one-time occurrence. The forklift ran into it, made the adjustments, get the skilled trade in there, make the adjustments on the machine to fix it. Now it's making good product. That's considered an assignable variation because we are identified and can correct it, and it's not something that's going to keep happening over and over again like these. These are the ones that keep happening that you can't do anything about it. Vibration is vibration. All right, is that it? Is that all we got?
Yeah.
Have a great lunch. I'll see you for our last lecture on Tuesday. Anybody else have assignments they want to hand in? Because you emailed them or you have no? Anybody that want to hand back these to those who came in late?